I want to start somewhere unusual, not with what this framework claims, but with a list of things it deliberately refuses to claim. Six birds reaches across physics, mathematics, lives, institutions, and honestly, when one idea spans that much ground, your first reaction should be suspicion. So before I ask you to take any of the positive claims seriously, I want to put seven stronger conclusions on the table that this program does not earn. And I don't mean they're merely awkward to admit. I mean the framework itself blocks them. The structure of the thing says you're not allowed to conclude that. Think about the kinds of leaps that feel tempting here. A theorem proved inside a finite model starts to sound like evidence about every natural system. A pattern that simply holds still starts to sound like a brand new layer of reality. A sequence of steps starts to sound like the arrow of time. And the same diagram showing up in a particle model and in a model of a city starts to sound like proof they share one underlying cause. Every one of those is a shortcut, and every one of them is blocked. So, how do we keep ourselves honest? This channel is going to lean on a ladder. Picture the rungs on the screen. A definition, then a formal theorem, then a computation, then a simulation, then an empirical landing, and finally a frontier proposal. Here's the rule that makes the ladder worth anything. You do not get to climb it for free. Standing on one rung never lifts you to the next. Every single step needs its own bridge that you actually have to build. With that rule in mind, let me show you the whole map at once. Here are the 7 hard boundaries, all of them laid out as the 7 things six birds will not say. Take a second to read down the list. Each one is a "this is not that." We are going to walk through them one at a time, and by the end, I want each one of these refusals to feel obvious to you, like something you would have said yourself. So, boundary 1. Here's the tempting positive claim, the one that I'm refusing, that six birds has shown every emergence event runs on one and the same microscopic mechanism. It has not shown that, and it does not claim it. So, what is the honest, smaller claim underneath? It is narrower, and I think it is more interesting. Six birds proposes a precise grammar of questions. A closure-and-audit grammar for asking when stable objects and genuinely new layers appear. Picture a little template you can fill in. What can this theory actually see? Which distinctions does it bundle together? Does the proposed update at a higher level actually close on itself? And how do we audit whether the answer holds up? Now, those questions may well be reusable. You can ask them of a proton model, of a piece of pure mathematics, and of an institution, and slot all 3 into the same carrier lens package audit table. But here's the move I want you to watch carefully. The questions being shared does not make the answers the same. The same template over 3 subjects does not mean the carrier material is identical underneath. It does not mean the causal mechanism is identical. And it certainly does not let a result in one row stand in as evidence for another row. You might be thinking, but doesn't the program have an exact 6 result? It does. And notice exactly how scoped it is. The result lives inside a declared finite formal setting with explicit recognition assumptions. It is not an assumption-free theorem that 6 rows exhaust every conceivable account of emergence anywhere. So the thing being proposed first is a common grammar of questions and shared failure modes. Universality, the idea that one mechanism underlies all of it, is a research claim still waiting to be tested. It is not a premise we get to assume for free. Boundary 2. A finite theorem, a clean little toy model result, is not automatically a statement about the real world. And I want to be careful here because it is easy to hear that as the toy is worthless. It is not worthless at all. Look at where these no-go results actually live. They are proved inside a finite, deterministic, coarse-graining setting. The relation on the screen behind me is one of 8 separate no-go results in that setting. And a construction like that earns real things. It can prove that two concepts are logically independent of each other. It can expose a shortcut as false. It can stress test an audit method under conditions you fully control. But now, what's the gap? The step from that controlled setting out to a natural system is a completely separate claim, and it has to be argued on its own. What might that argument need? Maybe a physical measurement model, maybe a scale transfer argument, or a continuum limit. Maybe a demonstration that the result survives when the model is slightly wrong, or a comparison against the standard baselines, or application on data the model never saw. Until those bridges are actually built, the honest wording stays inside the model and does not wander out. The lifelike paper says this out loud, and I think it is a good model for the whole program, although it was quite early, the Six Birds Foundations program. It does report control signatures in synthetic substrates. It does not claim that biological life was created. It does not claim autonomous open-ended evolution under one fixed externally steered regime. So, a toy can show you that a mechanism is possible or impossible, or simply useful as a diagnostic, all understated assumptions. What a toy cannot do is reach out and force nature to instantiate that mechanism by sheer rhetorical confidence. Boundary 3. And this one has a little machine I want you to keep in your head. Imagine a machine that takes absolutely any input you hand it and sends it to you in one single featureless dot. Every input, same dot. Now, run that machine on its own output. Nothing moves. You are already at the dot. So applying it again changes nothing. That machine is perfectly stable. It is as stable as anything could be, and it is almost completely uninformative. I love this example because it pries apart two things we tend to glue together. Stability and novelty are answering different questions. A stability certificate asks one thing. Does this object or package survive when you apply the declared completion rule? A novelty certificate asks a totally different thing. Does the new layer add a distinction, a prediction, an expression that you simply could not state in the old package? And then there is the third, separate certificate for directionality. 3 lamps, 3 independent questions. One can light up while another stays dark. A formed object can be rock-solid stable and add no new expressive power at all. A strict extension can add a genuinely new distinction and yet still have no closed dynamics of its own. And neither result on its own hands you any directionality. So here's the discipline that follows. When a later video tells you a package is stable, do not let your mind quietly promote that sentence into a new layer has been established. These are different certificates. The channel owes you the separate novelty test, and it owes you an honest "we don't know yet" when that test is unresolved. Boundary 4. Here's the claim I'm declining, that having an order to things gives you an arrow of time. A system can have a sequence, a schedule, even a protocol whose steps do not commute, and still produce no sustained time reversal asymmetry at all. Order on its own does not manufacture a direction. Inside that finite setting, the no-go results make this precise in 2 ways. And you can see both panels on the screen. The first is a kind of guardrail on observation. A deterministic, lossy way of looking at a system cannot create path-space asymmetry that was not already there in the underlying dynamics. Watching through a blurry lens never adds an arrow. The second is what I think of as a protocol trap. If the lifted system is reversible and you start it in its stationary state, then the observed arrow is exactly 0, even when hidden protocol coordinates are quietly supporting real order underneath. Now, notice what this is not saying. It is not saying real arrows of time are impossible. Drop the stationarity, add genuine non-equilibrium forcing, or supply a real affinity, and the theorem's hypothesis simply stop applying. The escape routes are right there on the screen, but the result says is something more disciplined and more useful. Do not read physical directionality out of ordering alone. So, Sequence dependence, protocol holonomy, directional scheduling treat all of those as diagnostics. They earn the name arrow only once the relevant asymmetry audit comes back positive under the declared conditions. Boundary 5. The tempting picture is that if you just keep running the same closure over and over, new theories will keep sprouting forever, an endless ladder of emergence powered by repetition alone. Two simple results say no. The first is about repetition itself. Look at the relation on the screen. If your packaging map is idempotent, then applying it a second time adds nothing whatsoever, and the same goes for every application after that. Once you have taken the one completed step, every later iterate is just the same map again. Running it longer does not climb anything. The second result is about the interface you're looking through. Suppose your lens is fixed and shows only finitely many visible states. Then it can only support finitely many predicates definable through that unchanged interface. The bound is on the screen, and you cannot squeeze an infinite, strictly growing ladder of predicates out of an interface you're keeping frozen. So where does real open-endedness come from? Well, not from magic repetition. It comes from an actual change of theory. The lens can grow, the domain can grow, the package can change, new instruments can come online. A different completion rule can be installed. So Sixbirds does not claim that you get autonomous open-ended novelty out of one fixed finite closure just by leaving it running. Open-endedness needs some genuine source of package or interface change, and that source has to be named and audited, just like everything else. Boundary 6. Here's a thing I'm genuinely allowed to do and a thing I'm genuinely not. Suppose I take a logic gate and an institution and map both of them into the very same audit fields: carrier, lens, package, closure, extension, and claim ceiling. Look at the two parallel tables on the screen. That comparison can be genuinely substantive. It might reveal that both arguments fail for exactly the same reason. Maybe in both the package is unstable, or the higher level load does not close, or the supposed novelty was definable in the old theory all along. That is a real, useful finding. But what's when you cannot cross? It does not mean an institution literally is a logic gate. It does not reduce social explanation down to particle physics. And it does not let a successful finite computation count as empirical evidence about a city. Every domain keeps its own substrate, its own measurements, its own background theory, and its own obligations to prove transfer. So the cross-domain examples on this channel are two honest things: teaching tools and research hypotheses. They make the shared audit grammar easier to grasp, and they help us design sharper tests. What they never do is erase the boundaries between fields or stand in for domain expertise. Boundary 7, and this is the one about the work itself. The corpus has a lot in it: definitions, theorem statements, computational results, simulations, code repositories, and some mechanized components. Those are all real kinds of support. And here's the honest distinction: none of them is automatically the same thing as independent validation. A theorem environment inside a manuscript tells you where a claim lives. It is a locator. By itself, it is not an outside party taking the proof. A public repository makes the work traceable, which is good. By itself, it is not someone successfully replicating the result. A lean manifest can certify the specific declarations it lists and their dependencies. It does not certify every informal sentence or every empirical implementation, or the whole research program around them. So let me say the status plainly once and then move on. Several of these manuscripts are preprints, and the registry this channel uses records independent validation as not assessed unless the documentation says otherwise. You can see that badge on the screen sitting empty. That is not an apology. It is an accurate label, and it is exactly why future videos will use carefully different verbs. A definition defines. A formal paper derives within its assumptions. A computation reports. A simulation demonstrates a behavior in a model. A domain paper proposes an interpretation or motivates a test. Source support is necessary. Independent checking is a separate badge, and it stays unfilled until it has actually happened. Now, I can hear the objection forming, because I would raise it too. Isn't all of this just preemptive excuse-making, a long list of things I get to not be responsible for? It would be excuse-making if the boundaries changed nothing in practice, but they do change something concrete. Each one alters the evidence the channel is required to bring, and the words the channel is allowed to use. Words then turn into gates. Toy is not nature means the domain bridge has to be supplied before we speak about nature. Stable is not new means the novelty certificate cannot be quietly skipped. Order is not arrow means the directionality audit has to come back positive. Same structure is not reduction means every field keeps its own evidence. And source support is not validation means proof, review, replication, and peer review stay as separate, honestly tracked statuses. 7 refusals, 7 concrete obligations. So, a claim ceiling is not a polite footnote you skim past. It is the strongest public conclusion that the present support actually warrants. Crossing it is an error, especially when the biggest sentence sounds more exciting. And that is the whole point. The non-claim register does positive scientific work. It tells you precisely what would have to be added before a stronger claim is even allowed in the room. With all 7 boundaries fixed in place, I can finally tell you the smallest, honest, positive claim, the one thing that 6birds does stand on for sure. Here it is on the screen, surrounded by the 7 boundaries that keep it honest. 6birds proposes a precise closure and audit grammar for asking when stable objects and new layers appear. And notice how the support splits into separate lanes, each with its own status. Within declared finite assumptions, parts of the program derive formal no-go results. In declared computational models, other papers report controlled demonstrations. And domain papers propose bridges that still have to be tested with domain-specific evidence. 3 lanes, 3 different kinds of support, never blurred together. That is already a demanding program, and I think that is the appeal. It asks every single Emergence claim to name its carrier, its lens, its package, its update law, its certificates, its controls, its status, and its ceiling. And it gives us principled grounds to reject a claim outright when those pieces are missing. In the end, this framework might turn out to be broadly useful, or less useful, hopefully not. I would rather keep all of these 3 possibilities visible than hide them behind our grant label. So use these 7 cards as your standard for every video that follows, and hold the channel to them. And now that the boundaries are out in the open, the next video does the opposite job. It gives you the positive claim in a single sentence, no slogans and no free passes.